Hello everyone, and welcome to today's presentation on secure protocols under network security. Secure protocols are communication protocols that provide secure communication between two parties over a network. They ensure that data exchanged between the parties remains confidential, integrity is maintained, and the authenticity is guaranteed. So we have two types that we want to discuss today, and the first one is SSL and the other one TLS. So say SSL, secure socket layer, TLS, transport layer security, and I explained that they provide secure communication over networks by encrypting data and ensure its integrity. So they are widely used to secure sensitive transactions such as online banking, e-commerce, and secure email communication. They use encryption, decryption, and authentication mechanisms to ensure secure data exchange. Then we are talking about SSL. This one is a secure protocol developed by Netscape in 1994. It provides end-to-end encryption between a client and a server, and this one ensures that data exchanged between them remains confidential. So when you access a website using HTTPS, your browser establishes an SSL connection with a server. This ensures that any data you enter on the website, such as login credentials or credit card numbers, is encrypted and secure. Then we talk of TLS. This one is a secure protocol developed by the Internet Engineering Task Force in 1999, and it is an extension of SSL protocol and provides additional security features. Right? So when you access a website again using the HTTPS, your browser may establish a TLS connection with Google servers instead of an SSL connection. This provides additional security features such as improved encryption and authentication. Now we want to move on to SSL and or TLS, handshake process. This one is the process by which a client and a server establish a secure connection. It involves a series of steps that ensure the authenticity and integrity of the data exchanged. Right. So the TLS SSL handshake process involves the steps that are given on the screen. The first one is the client hello. This one initiates the SSL TLS handshake by sending a client hello, right? So this one initiates the handshake by sending a client hello message to the server. So this message includes the client supported SSL TLS versions, the client supported cipher suits, and a random session ID, right? So we are saying that the client initiates the handshake by sending a client hello message to the server, indicating its supported SSL TLS versions, cipher suits, and other parameters, right? So your browser sends a client hello message to Amazon server, for example, indicating that it supports TLS 1.2 and AES 256 encryption. This is what we are saying, the initiation of the handshake by sending a client hello. Then we move on to the second step, which is the server hello. This one, the server now responds to the client's client hello. This is a response to the client hello message with a server hello message. Now there is a server hello message. So the message, right? This one is selecting the highest SSL TLS version and the cipher suit that is supported by both the client and the server. So this server hello is a response to the client hello message. And this one includes the server's chosen SSL2S version, then the server's chosen cipher suit, then and also a random session ID, right? So Amazon, for example, the example that we gave on client hello, now Amazon server responds with a server hello message indicating that it has chosen TLS 1.2 and AES 256 encryption. Now moving on to certificate exchange, this one, the server sends its digital certificate to the client, right? So this one is the server sends its digital, and take note, the server sends its digital certificate to the client, which contains the server's public key for encryption and identity information. This one is the client then sends the encrypted session key to the server, right? So your browser generates a random session key and encrypts it with Amazon's public key. So your browser then sends the encrypted session key to Amazon server. Then we move on to the fourth step, which is the client key exchange. The client key exchange. The client generates a random session key and encrypts it, right, with the server's public key, then send it to the server. So the client then sends the encrypted session key to the server. So your browser generates a random session key and encrypts it with Amazon public key. Your browser then sends the encrypted session key to the server, right? So then step number 5, there is a session key generation. Both the client null and the server independently derive the session key, right, based on the exchanged information. So your browser and Amazon server, the server that we are using, independently derive the session key based on the exchanged information, right? Then step number 6, this one is encryption. Then the client and the server use the session key, right? Both the client and the server use the session key to encrypt and decrypt the data exchanged during the SSL2S session, right? For now, the example is that your browser and Amazon server use the session key to encrypt and decrypt the data exchanged during the SSL2S session, ensuring that your login credentials and credit card numbers, for example, remain secure, right? This marks the end of our lecture today on secure protocols. Thank you for your attention, and I hope this presentation has provided you with a good understanding of secure protocols and the SSL TOS handshake. Thank you.